So this lecture is actually a little bit different than other lectures we've had before. Today's lecture is about the design of your tic-tac-toe assignment. And so one of the things you've heard me talk a lot about is the difference between just writing the C# syntax and actually being a software engineer. And one of the things about a software engineer is that you just want to make sure your problem solving skills are on point. And so what I mean by that is you have this problem that your customers came to you with, like you need to create an invoice system for small business, or in this case, let's say a customer's come to you and says, "Hey, we want to create this tic-tac-toe game for kids or whatever else." And so okay, I've got this. So now how do I go about solving this problem? So I sit down, I figure out what's the best language to create this in. There's lots of great options. And let's say your background's in C#, so that's what you settle on. So now you figured that out. So now let's talk about how you go about dissecting the problem in order to solve it. So this is where you can start writing out some pseudocode and you would write out designs. And again, the more complex the program or problem you're trying to solve, the more designing you're going to have to do, the more people you're going to have to work with, and those kinds of things. So in this class, we're not going to be writing any UML out to mimic out, but in the real world you would. You would sit down and you would think through, what type of classes you're going to need. Other people are going to think about what type of classes they need. You're going to have an architect designing it all out where that, hey, here's these shared classes that multiple developers are going to use, or shared controls and things like that, how you get the same common look and feel. And then you're going to take your little piece of the puzzle and you're going to design it out and say, I'm going to need this class to do this and this class to do that. And then you start working through all the attributes and all of the methods. And you can create that in UML, and then you can start doing and saying, you say, okay, well, I noticed this part right over here. There's a really complex algorithm. Maybe we're doing the extra credit for the tic-tac-toe program, and that's some high risk on being able to make this AI productive and actually fun to play against. So maybe this is something you would actually write some prototype code for, and so you would just write out pieces of what you would call AI for tic-tac-toe and make sure that it's actually playable and it works and that it's fun. And so that reduces your risk when you actually go into your real code that you write for tic-tac-toe. And so for this class, what I'm going to show you is a way to just sort of design out and stub out your code that I would recommend to do for the remainder of your assignments to sort of help you get it done and to figure out the best way to solve this problem. And by doing this, it makes you think through the problem and you kind of stub out the code that you can just sort of fill in later. And I promise you, doing it this way, it'll make your code so much more readable, maintainable. You'll actually get it done faster in the end, and you'll have less bugs and problems to deal with. I promise you, spending 10-20 minutes up front to get your head wrapped around the assignments versus just going in and just start typing and grabbing a button and double clicking and then writing the code. I see that all the time in students' code, and I can tell just by how much code you copy and paste, the structure of it. When you send it to me, hey, I had a question about this particular part, and I go look at your code and I can see how sporadic it is, and it's not really coherent at the time. So that's kind of where this lecture comes in. So let's take a look now. So we've got this tic-tac-toe program, and we think to ourselves, okay, what I'm going to first do is I'm going to design out my user interface. So you say, okay, I'm just going to start building the UI, and then lots of times when you build your UI, it helps you to get your head wrapped around some of the big problems you're going to have. So maybe I'm going to drag a label on here, and I'm going to bring up the properties, and we can expand this up and we can say, okay, just for fun, I'm going to set this to X because we know that, and oh, you know what, that font size is going to need to be a lot bigger. Let's go ahead and order these. So we come up here, let's get rid of auto size. Let's set that to false. So I can actually go ahead and let's say that this is the size of our tic-tac-toe square. Oh, okay, I'm also going to need to set the alignment here. So we're going to come down here, we start scrolling up and down, and we say, okay, how do I do my alignment? Oh, there's text alignment. Sure enough, there I can go. I can set it to my middle. I know my font, I have no idea what to set this to. Let's do a 30, not even close. Let's do something like 60 or 90. There we go. That's nice. Hey, maybe we should make it bold. You can play around with fonts or colors, whatever you want. And you kind of just get a general idea. And then from there, you can copy and paste, and you can kind of get an idea of how you want to set up your board. Same thing maybe with create another label here. Do auto size to false. Set the back color to, let's just do, black. And maybe here we'll use this, for a column. Again, it's just one way that you could do, hide your columns here for your game board. Okay, and I also know that I'm going to have, some statistics on here. So I'm going to come in here to my containers. I'm going to have a group box, kind of lay that out. I'm going to have some labels in here for my, things. I'm also going to have another group box or something where that's going to have, the user status on there. So I grab my group box, drag it down here. And so this is where my status is going to be. It's player one's turn, it's player's two turn. So you kind of go through the motions of creating your entire UI. And so now, again, you think through the problem where they're going to be able to start the game. And so we're going to need a button on here. And so this is our start button. So we can come over to our text, change this to start. And so now we say, okay, well, I've clicked start. I know that at that point I'm going to have to clear my UI. I can then start entering, clicking on the different, UI portions of my board. And then, depending on what square they click on, I'm going to have to fill it in with an X or an O. I'm going to have to make sure it's blank. And then, oh, by the way, all right, if three are the same, I'm going to need to make sure that it's a winning move. If all of them are filled in, I'm going to need to make sure it's a tie. All right, so I'm kind of getting my head wrapped around this entire problem now. I'm thinking through it. So part of the assignment also requirement was that you had to have at least one class to do this assignment. So we know this, so we're going to have some sort of class that contains our business logic for tic-tac-toe. And what that really means is that with all your programs, you want your user interface to only have code specifically to the user interface, changing colors, highlighting winning move, updating the statistics, those sort of things, handling button clicks. But this user interface shouldn't know anything about what a tic-tac-toe win is. It should just know how to display the win. It shouldn't know anything about a tic-tac-toe tie. It shouldn't know anything about the AI if you implement the extra credit. All of that code should be in a separate class and not behind this user interface. This user interface can call that code to say, hey, is there a winning move? It asks the business logic if there is a winning move, and then it can take its appropriate actions, but it doesn't really understand what's going on in the program. I always think of it as I try to make my user interface as dumb as possible, and I only try to write as little code as possible that just deals with the user interface. Everything else I try to pull out into a separate class. So for instance, let's come over here and let's right click. Let's say add a new class. And so we're going to create ourselves a tic-tac-toe class that's going to hold our business logic. So we say CLS tic-tac-toe. So now we've created this particular class. And let's go ahead and make this public. Sometimes you can run into problems if you don't do that. So now I think through the problem here. One is that there actually was a requirement that you had to be able to pass the game board into this class, right? That was something I said. However, when you look at this, okay, what I have to do is as the user clicks start and starts filling up the game board here, so I've got all these rows and columns, all of these labels, I need to be able to pass this information into my game class, this CLS tic-tac-toe. So what I can do is I can say, okay, this is just basically a multi-dimensional array, right? 3 rows, 3 columns. I fill up this string array, and then I pass that into my tic-tac-toe class. So what I could probably have is a private attribute, something that's like a string that's a multi-dimensional array called SA board, for instance. Now you notice I haven't actually instantiated it here because you would do that inside of your constructor. The next thing we want is, okay, we also know that on our user interface we have all these statistics we have to keep track of. Player 1 wins, player 2 wins, and ties, things of that nature. So I'm going to say private int player wins, player 1 wins. And then maybe, player 2 wins. Or, player 2 or AI wins, depending it. And so there's only one other variable that we need to do here as far as the statistics goes, and that's I ties. So we can keep track of how many ties. So if player 1 or player 2 doesn't win, we can keep track of ties. So the next thing is that we know that as we go through, we're taking this game board and we're going to pass it into our class. And so we start thinking through this. Okay, I filled up the game board, and let's just say this is the way the game board looks like right now. And so I have a winning move. So I pass the game board in, and then I do some processing, and I know now where the winning move is at. So I come back to my UI. How am I going to know where that winning move is located? Right? So I have to ask this business logic class, hey, was there a winning move? And oh, by the way, if there was, where is that winning move? All right. So there's lots of different ways that we could return that piece of information, because the UI, as far as it's concerned, it just wants to say, was there a winning move? Yes. Okay, tell me where I should display it, and the UI will then highlight the appropriate row, column, or diagonal move. So one way we could do that is through an enumeration. So we could say private enum winning move, and now we could define all the ways or all the directions that they're winning moves. So row 2, row 3, call 1, call 2, call 3, diag 1, diag 2. So this winning move now, this enumeration defines how we're going to return where the winning move was located. So we also need a private variable of type winning move called eWinningMove. So this will be set later on in our program, and we'll actually have a private property that accesses this, that the UI can call and say, hey, tell me where the winning move is. It accesses the public property for this winning move, and it just starts looking through. Was it row 1? Was it row 2? And then highlights those accordingly. So again, for all of these attributes, we're actually going to have a public property that ties into that. So now let's think through what we're going to need to define for our game itself. So as the user is clicking on these, we fill up our game board, we pass it via a property into our class, and then the first thing we need to ask is, hey, is there a winning move? We need to know this. So let's just go ahead and create a public method that returns true or false whether there is a winning move. All right, so now I've defined this logic for there is a winning move. Well, if there isn't a winning move, what does it also have to test? If it was a tie. So okay, so I'm going to have a method called isTie, and that's going to return a true or false to you. So now the user interface can say, okay, was there a winning move, yes or no? If the answer is yes, so this algorithm is where you're going to write your code now to just loop through the array, look through rows and columns, and determine. Let's say that as we're writing our logic here, it goes and finds that row 2 has the winning move. Well, what we do then is inside this winning move, we see eWinningMove equals winningMove dot row 2. And so then now that this is set, the UI just accesses the public property for this, and then it knows where it can assign the winning move, or highlight it on the game board. And then it'll then say, oh, there was no winning move. Okay, now was there a tie? So the other thing we can think through is we say, okay, let's pretend that this is actually really, really complicated code here. It's not, but we're going to pretend. So for a winning move, is there ways that we could abstract that out or write little private helper methods to figure out where the winning move was? And one of the ways we could do that is by writing, we say, okay, what we really want to test for is if there's a horizontal win, if there's a vertical win, or if there's a diagonal win. So maybe we say private bool is diagonal win. And we do the same thing now. For vertical win, so vertical and horizontal. And so these are just private methods that are going to be called within isWinningMove. So in here, we're actually going to say if isDiagonalWinningMove equals true, then we know, then this will actually set which diagonal win was the move. If isVerticalWin equals true, then this will set, this enumeration true or false. Is horizontal win. Now, what's nice about abstracting it out this way, because you may say, well, that's so simple, I'm just writing a bunch of if statements up here, why would I want to break them out this way? Well, now again, imagine someone coming into your program 10 years from now, and this is really complex logic, And as they're running your program, they notice that there's a random bug that sometimes the horizontal winds are not showing up correctly. Well, if you've abstracted your code out this way, it's probably really easy to find the method where that bug probably exists, which is horizontal win. So this person can come in here and they can, just by reading through your code, they can now say, okay, I've got this is winning move. Oh, it's calling these little helper methods that, oh, it's probably the bug's probably in this. And they can set a breakpoint and start debugging from there on. And so that's what's nice about really abstracting out your methods to do very unique and distinct things and just do one thing only, like determining if there is a win or is there a tie or a specific type of win. So now let's come back to our UI again. And so now we're actually going to use that other class. So we can come over here and view our code. So now we've got our form. So we know in our form now, the first thing we're going to have to instantiate is our Tic Tac Toe class, right? That was our business logic. So we'll call this CLS Tic Tac. Now again, we don't ever want to instantiate this as a class level attribute. We only want to do this inside of our constructor. Now the reason for that is, especially when we get into exception handling, is that if we ever to use the new keyword up here, there's no way to handle the exception that gets thrown. So if it ever crashes your program, there's no way to handle that. Where here we can use a try catch block, which we'll learn later on, and we can actually handle that error appropriately. So the other thing now is we start walking through the game itself. So we have our form, we bring our form up, and we say, okay, I don't want the user just to be able to click buttons. You know what I actually want to happen is for them to click the start button first. So I say, okay, I need to make sure that the game has been started. So I actually create a variable called bool is game started. And I'm going to initialize that to false, because it's automatically initialized to false, but let's go ahead and do that. So I've now created my attributes that I need, and I've created a constructor, and then I'm probably going to need one more, which is, there's two ways to do this. Either I can create basically a board here that I fill up, or I could even just fill up, I could access my tic-tac-toe game board and just fill it up from there using the property. So what I mean by that is I can just say tic-tac-toe dot board. Whoops, there's no public property. So just real quick, let's just make this public so you can see what I'm talking about. So here's this board. So if I wanted to, see, I could actually just come in here and I could set these this way. Or I could create a string board here, fill it completely up, and then just set the entire board equal to this, like that. So there's different ways that you could pass the game board in. Just set the properties or access each individual element or fill up a game board and then pass it in. It's up to you. So now we come in here and we know, okay, well, I've got this start button click. So this was our starting the game. So we start thinking about that. Okay, now what I'm going to have to do is set my B game to true. So again, you could write this, or another way you could have done it is, let's say it was a little more complex, you could just write a comma here. Need to start the game, do some logic, or set B game variable, something of that nature. So even if it's really complex, you could just describe what needs to happen here in your start. Now we come back and we think to ourselves, okay, well, what happens if the game's in this state right now? The user has won. What else are we going to want the start button to do? Well, we're going to want it to reset our game board. Well, there's two things that are probably going to need to happen to reset our game board. We think, okay, one, we're going to need to reset each of these labels, and then on top of that, we're going to need to reset the winning move, wherever that was at, or if there's a tie. So we need to reset all of the back colors. So again, we just think to ourselves, okay, well, what I probably will need, and maybe we just make ourselves a note, create a clear labels method and a reset colors method. And so we make ourselves a note, and then we say, hey, we're actually going to be calling these maybe right here. And so we just kind of stubbing out our code and just trying to understand it a little bit. So now we have two methods, and again, they're very distinct on what they do. This one just clears labels. This one just resets colors. So as you're writing and you're developing your program, you start running it and debugging it, and you notice one of your labels is not getting reset, it's really easy to find and maintain and fix that code where it's at. So there's really only one other thing in our game that can be done, and that's basically they've clicked on a label. Now, when you're thinking about this, what you don't want to have is 9 different label clicks, right? Since we have all of these, and I'm holding down the control key and just moving this down. What you don't want to have happen is have 9 individual button clicks, because you're always doing the exact same thing. What you want to do is to have one label click for all of your labels here. So there's the easiest way to do that is to come in here and highlight all of your labels, and then you can either just double click here in the click method, or you can actually name it something. So this is space click. The user has clicked a space, press enter, and now you'll notice that there's only one method that gets called no matter which label you get click. So okay, so now you need to be able to figure out which label got clicked. And there's various ways you can do that. One way is you could maybe just look at the label name itself. So I could call this one, LBL00. This one LBL01, so that you could just then look at the name and you would know which label got clicked. And then so via the name, you could then determine which index in your string array board to set to an X or an O based on what the user has clicked here. Another way that you can do that is through this tag property right here. Now this tag is an object type, and you can set it to anything you want, and it's just a way of sort of attaching some data to a UI element. So for instance, for this one, I could just set the value or the string 0, 1. I could set this one to 1, 2, for instance, and so I'm just setting the location. So then in my code, I could access the tag property in order to figure out what the index of that label that was clicked. So I also have a sample program that let's take a quick look at here that I've created, and it's posted on Canvas. And it's this Tic Tac Visual Elements helper program. And so what it's going to do for us when we run it is you'll see that each of these labels are assigned the same click method, and so I'm just showing you how to do that. And so again, I've assigned, if we come in here to properties and we take a look here, you'll notice that we've got LBL space click, and that's for all of these labels. Then when we come into the code here, here's that LBL space click. Now you'll notice that we have this object sender here. So what this is saying is that this variable is going to contain the UI control or object that raised this click event. And so I've only got labels right now tied to this LBL space click. However, I could have also tied it to a button, and that's why it's an object type, because anything could get passed into sender. So now because it's an object type, that label got boxed into an object type, we have to pull that label back out. So here's that sender object. We have to cast it to a label, and then now we can create a local reference to whichever label got clicked. And now that I've got this local variable here of my label, I can just set the background text to X, and the color, I'm going to then pass in this entire label to the set background color. Notice I pass in the label, and I'm just setting its background color. So no matter which label I click here, it's all going to call this same method. So when I click here, this sender is going to contain the object of this label. When I click this one, sender is going to click the object or contain the object here. I just have to cast it and be able to use it. So let's go back to our tic-tac-toe board now. So now, like I was saying, we've got our label click for all of these different methods. So we've got space click in our particular example. So we start walking through that. So what's the first thing that we're going to have to figure out when we start playing our game? Well, imagine the form first starts up and the user starts clicking labels. Should we allow them to do that? Should we allow anything to be put in here? No. Why? Because the user hasn't started the game yet. Or let's say the game is finished and we have a tie or someone has won, and I start clicking labels. Well, nothing should happen because the game should not be currently being played. So the first thing we want to do is test to see if B game has started. So we say, okay, the first thing I want done is, look at this B game has started. So that's the first thing we want to do. Then we say, okay, has the game started? Let's say it has started. So what's the next thing we want to do? So we think through it and we say, okay, well, in this instance right here, let's say the user clicked this label. Well, it's already taken. Well, so if this, we have to make sure that the space is blank. So is the space blank, right? Because you can only do blank spaces for another thing. So next, we've determined that the space is blank. Okay, so what do we need to do now? Well, we need to now load up our game board to pass it to our Tic Tac Toe class. So we need to load our game board. So maybe what we actually want to do now is let's write a method, and so we'll actually create another method here. So we make ourselves a note that we're going to write a game board or load board. And so that'll loop through all the labels and figure out which ones need to be loaded and passed into that class. So now we've loaded the board. So what's the next thing we need to do? So we need to determine if there is a winning move. So we've got our Tic Tac Toe class up here. So we say to ourselves, okay, so we're going to do this. We're going to say is winning move, right? And we can write this. We kind of stub it out. I'm going to determine if there is a winning move or not. So what happens if there is a winning move? Okay, so we said, is there a winning move? We checked that enumeration. We can check the enumeration now and we can highlight where that winning move is. So we say, okay, you know what we want is to highlight winning move, and I'm going to create a method for that. And now that we've highlighted the winning moves, what we actually have to do is let's also create a method, something like display scores, because I'm going to need to update my statistics on my game board. All right. So what happens now? Then we have to actually stop our game at this point because there was a winning move, and we set the B game play as the game started to false, and or we can set it still set to true, but we don't allow any more ticks on the game board because the game's done. So now what happens if there was no winning move? Well, now we need to check to see if there was a tie. So we tic-tac.is tie. And so what happens if there is a tie? Well, then the game's over. And so we can set the game to over and we can display the scores. All right. So then we say, okay, so what happens if there wasn't a tie? Well, nothing. There's nothing else to do, right? The user is still playing the game. So we just allow them to keep clicking spaces and going back and forth, with this method. So that's kind of a way that you can take a problem and break it down into smaller little chunks in order to solve the bigger problem at hand. And hopefully, again, with tic-tac-toe, this is sort of a manageable little problem to do in a lecture, but you just get better and better at this so that when you tackle these huge problems in the real world, you get better and better at being able to figure out, these kind of methods and classes that you'll have to abstract your code out in.